Welcome everyone to today's webinar about deep learning applications in offline face verification, recognition, and clustering. Thank you so much for coming, for attending this webinar, and we hope that you will get to learn a lot by the end of the session. So in this webinar, we'll cover why face recognition is an industry disruptor before discussing some salient face recognition architectures. And finally, we'll see FaceNet, a face recognition tool developed by Google in action. So you will get to see a demo of FaceNet. You will get to see it in action. My name is Shweta Joshi, and I'll be your host for the next hour. So before we begin, let me just go through a brief introduction about the speakers. So I am a marketing communications manager at Nitar Infotech, which is a leading software product development company. We build world-class products and solutions by combining cutting-edge technologies for web, cloud, data, and devices. Nitar is an AI-first company that builds artificial intelligence capabilities into our service offerings to deliver business value. At Nitar, I like to think of myself as a wordsmith, and it's my job to take complex information and make it easy to digest. I have here with me my colleague Akshay Deshmukh, who is the principal AI architect, as the chief presenter for today. Hi Akshay, thanks for coming.
Hey, hi Shweta, it's a pleasure to be here today.
Akshay is a Microsoft certified AI engineer with a focus on machine learning. He has built multiple chatbots as part of his varied projects, and he also has 9 years of rich experience in the IT industry. He is also a cloud developer and architect and has worked extensively on AWS and Azure. Okay, so Mukul Joshi, who was our presenter, he has nominated Akshay to be the chief speaker today. This is because Akshay is the face of AI ML at Nitar and has deep expertise in various face recognition architectures. He has created multiple POCs or proof of concepts and MVPs or minimum viable products for clients of international repute. He is the go-to person for anything related to AI. So I'm very happy to have Akshay here today, and I think we're all lucky that such an experienced person is speaking to us. Okay, so just a few pointers before we get started. If you have any questions during the presentation, please type them into the question box in your GoToWebinar control panel. I'll bring them up during the presentation, and we will also have time for questions at the end. All right, Akshay, over to you.
Okay, thanks Shweta. I appreciate the introduction. And it's great to be here speaking with all of you today here. So let's have a look on our agenda today. So I'm going to talk about the face recognition in general and a couple of slides regarding the deep learning and more specifics of the convolution neural network. Then we will check out the faceness implementation, followed by the demo application built using the FaceNet. So let's start with why face recognition. First of all, the face recognition is a biometric benchmark to compare and verify the identity based on facial contours. So if these applications are implemented properly, then security will be top-notch. So let's look at the market value of the face recognition and verification domain. So it's a $3.2 billion as of 2019. So, but as per the market study by Markets and Markets, it will grow up to $7 billion by 2024, and with the annual growth of 16%. So it's a very huge number, right? So major growth drivers for this growth is the use of mobile and wearable devices and a leap in the demand of the robust fraud detection and prevention systems. And lastly, the increase in the data security initiatives by government. And I must say, the North America holds the largest market size of this domain or of this industry. So let's talk about what giants are doing nowadays or doing from last 4 to 5 years. So take giants like Google, Apple, or Facebook and Microsoft regularly publish their theoretical discoveries in the field of AI, image recognition, face analysis. So a Chinese university from Hong Kong, they have published their model in 2014, which has the accuracy of 98%. Which is quite higher than the humans, and they call that algorithm as a Gaussian face algorithm. Then Facebook came with their deep face, which has an accuracy up to 97%. After that, Google come up with the FaceNet that we are going to discuss today. That FaceNet come up with the record accuracy of 99%, which is quite high and very much ahead of all the other models we have. So we have seen 20x improvement, I must say, and 20x improvement in the accuracy over last 4 years. And in its 2018 test, NIST found that 0.2% of searches are getting failed, rather than 4% of data is getting failed from the 2014. So it's a very much high increase in the accuracy from last 5 years. Okay, so, and we must say that face recognition and face detection techniques can be used in the multiple applications in the mainly into two domains like security and health. And there are some multiple applications as well. So let's look at the some of the use case, domain specific use case, I must say. So in the security domain, so we can have the issuing identity docs and combined with fingerprints. So it can be used by the government authority organization to provide such kind of documents to the specific person, or including the specific information of which is kind of a biometric. Then criminal identification and authorizing and verifying the payments that can be done for various payments options. So currently we are getting digital in India, and all over the world is moving to the digital currency and all. So there are various options available and various use cases available in verifying your payments. Currently all things are in the username and password based, so that can be converted into such systems, which includes the security. It can also help in the finding missing persons generally. So you might be knowing that China has a very strong AI system where they have collected the data of each and every person's face and all, and they detect when they are traveling over the road. So in the next domain is a health domain. So there are a couple of we can say use cases. So two predominant use cases can be the help to the blind people to better understand the social situation, because they cannot see the person's face or expression. So they are understanding everything from their words. So this system, the facial recognition system, can help them to better understand what is the real meaning behind the words. Then it can also help to diagnose the diseases which are dependent on, or which can be detectable by the appearance or facial expressions. So one of the rare disease that DiGeorge syndrome, which can be there is a portion of 22nd chromosome is missing. So that can be identified using the facial recognition, and the system developed for detecting that syndrome is has an accuracy of the 96%. So it is predicted true in 96% of the cases. So and other use cases we can think of, like identifying the people on social media. So Facebook also has this embedded into their system to identify the users from different images, as well as iPhones also having this type of concept since long. Then tracking school attendance or employee attendance, and you can prevent the proxy attendance in exam or any seminar or any useful uh, organization. So offer targeted ads based on the person's characteristics. So from the face, you can identify the age, gender, and various other things of the person or other characteristics. So on the basis of that, we can create the ads so that we can target the right audience for the particular product. Okay, so that's all about the why face recognition and how much it is growing, and from last 4 years what is happening in that area. Okay, so all of the things are happening, or suddenly the machine learning is taking over all over the intelligent applications. So deep learning is one of the best part of the machine learning. So any image recognition, image verification techniques are currently based on the deep learning technology. So we are going to see why deep learning. So one of the most predominant reason is the zero domain knowledge. So I just want to talk about the era before the deep learning. So in that at that time, if any research paper is getting published regarding the image classification or object detection, the first couple of pages were only about the features, what features are being considered from that image or any object for that research. So in case of the image classification, there might be the features like maximum colors are getting used or maximum ages in that image. In case of the face detection, we might have the features like ratio of the distance between eyes and nose, that kind of stuff. So every researcher needs to work extensively on the feature extraction to come up with the better accuracy. But in the case of deep learning, you don't require the domain knowledge, strong domain knowledge, I would say, to extract the features, because it will does it automatically, and that will be done by your computer using the neural networks or convolution techniques and all. So which reduces the effort of the researchers significantly, and researchers can now focus more time on the architecture of the neural nets to increase the accuracy. Okay, so secondly, we have a great accuracy with the used data. So I have a very classical diagram or classical graph analysis, I would say, amount of data against the performance. So you can say that older learning algorithms like current machine learning algorithms, if they have achieved some certain level of accuracy with the maximum data, that is going to be continued if even though you have increased the data for the training. But in case of deep learning, as data increases, the accuracy of the system goes on increasing. So that is very interesting stuff, and that's why deep learning is being popular today. So due to automatic feature extraction and very much high accuracy, deep learning models make the complex task easier. And these complex tasks nowadays are computer vision, speech recognition, and natural language processing. So all of the things or few of the things are getting used in the language translation, we can say, or finding the right description for the image, or tagging the person, or finding any object in the image. So we have understood why deep learning. So let's have a look on the steps involved in the deep learning project. So there are 4 steps. Basically, we have sample data. More precisely, I will say that batch of data. That is, we have a lot of data, but for one pass, we use the samples, some of the samples from that data that are being passed through entire network, and through that network, neural network, it will start assigning the weights and finding the weights, and after the weights it has an activation function. So on the basis of the weights and activation function, it start activating the neurons. So final prediction will depend on the which neurons are getting fired for particular input. After those neurons are getting fired, we'll get a predicted output, and we'll run it through the loss function, because we know the actual values what we require, and we know the predicted values. So loss function will compare those two values and find out what is the loss currently with the current training, and it will back propagate through entire network to modify its current weights and some of the biases, I would say, to find out or to come up with the better predictions which give us the better accuracy. And fourth step is the update network weights. So these are the 4 steps involved in entire deep learning training process. After the training process, we will remove we will not have the loss function and the update network weight step. We will have only the model with us or weights associated with that, and we are going to run through that data and get the output. So we have understood how deep learning works. So let's understand one of the part of deep learning neural networks is the convolution neural network. So first of all, what is convolution? So convolution is in the mathematics way, we can say that convolution is a process to combining the 2 functions and finding out the third function, which is quite similar to one of the previous 2 functions. Okay. So let's see, if we have a neural network and we want to give an image as an input to that network, then if I have 20 by 20 image with the three colors, then I will have 20 into 20 into 3, that is 1200 input values for that network. And that is that number is very high only for the 20 by 20 image. Nowadays we captured our images with the DSLR, and our mobiles are also having AI technology and very high resolution cameras. So we are getting very high resolution images, and if we convert them, or we what we say, if we convert them as an input, then we'll have a large number of values as an input which are connected to the next layer. So in between these two layers we have very large number of connections, and that will increase the compute as well as the saving cost of this. So to reduce that, we can have a convolution in between the input and actual neural network. So convolution is a step that we are converting an input image into the meaningful other form, so that we can give it to a next network and it will be processed efficiently. So this is the concept of convolution in convolution neural network. Okay, so we can call the CNN as a regularized multi-layer perceptron. So multi-layer perceptron is nothing but our neural network where we have number of neurons and different layers of neurons which are connected to each other. So there are three main steps or concepts, I would say, in the CNN. That is, first is convolution, which I have explained earlier. Then we have a ReLU layer. ReLU is nothing but the activation function, I would say. So on the weights and biases, some value is getting calculated, and on that value, activation function has been applied to decide whether that neuron is getting activated or not. So ReLU is not a single activation function, I would say. There are multiple, but ReLU is getting popular from the 2014 when it was used into the AlexNet. Then pooling. So to reduce the dimensions or reduce the information, pooling is used actually. So there can be a max pooling as well as the average pooling. So max pooling is, as its name suggests, finding out the max and taking it for the next processing, and average pooling is taking the average of all the pixels or all the data and you process it for the next one. So in the diagram you can see the what is the flow of that. So first convolution happen, then we can have a max pooling, then we can have a activation layer, or we can have max pooling, or we cannot have. That's up to us. And after that we can have a fully connected layers, that is the neural network layers, where all the neurons are getting fired as per the activation. Okay, so this is all about deep learning and CNN, convolution neural network. Okay, so lot of before the 2014 there was quite a less work was happening into the image recognition and image object detection area. So ImageNet competition has been started from that. So to promote all the researchers to work in this field and to make this field happening, as well as to come up with the better models which can be used into the image recognition field or domain. So first winner of this ImageNet competition was the AlexNet. So here you can see in the diagram there they have a various convolution layers like convolution 1, 2. So blue ones are the convolution layers and yellow ones are the max pool layers. So here pooling is used but with the max pool. So there are important features about AlexNet. First use of ReLU is done in the AlexNet. Then there are normalization layers are also there, which are not common at nowadays. Nowadays, normalization layers are not getting used into the neural networks or convolutions. And it is using stochastic gradient descent, (HD), for the minima calculation and loss function and all kind of stuff. And more interestingly is that it has reduced the error rate to the 15.4%. Means its accuracy has increased very high, and that error rate is being calculated on top of on the top 5 categories which are predicted by the model. So next model is the ZFNet. In 2013, so two guys have come up with the ZFNet, and it is quite similar. I would say it's the same as AlexNet, but in the AlexNet, they are using the filter size for the convolution is for 11 by 11 pixels. But in the AlexNet, they are using convolution 1, they are using 7 by 7 filter with the stride of 2. And for other convolutions, for convolution 3, 4, and 5, they are using 512, 1024, and 512 for the rest of the convolutions. This is the main difference between the AlexNet and the ZFNet. And it has reduced the error rate by the 1% to 14.8%. So it is again an interesting thing that only changing the filter size and stride number, it has increased the accuracy by the 1%. After that, in 2014, they have come up with the VGGNet, which is quite interesting that they have kept the convolution filter size same throughout the network, that is 3 by 3. For each convolution layer, they will have 3 by 3 convolution with the stride of 1 and padding of 1. So padding is nothing but adding extra values to your image. We can say copy. It can be a average padding, or you can just copy paste the corner pixels to increase your image size, so that convolution can happen as per your filters. And other thing is that it uses maxpool with the 2 by 2 matrix with the stride of 2. But it has, as it has a very small size of filters, it will it will give us the output with the very large number of parameters, and that's why it has a high memory requirements than the previous net. So, and you can see the error rate has decreased by half. That is, it has come to 7.3%. So this is again a good achievement in case of the ImageNet. So next thing is GoogleNet. On the same same year 2014, Google has come up with the GoogleNet. So there they have used the concept of the inception module. So main features of this GoogleNet, there are 5 million parameters and no fully connected layers. So convolution is happening, or inception modules are there till the end of the prediction. Okay, so it has the 12x less parameters, but it has 2x more compute. So you can see in the inception module, you have multiple convolutions on the same layer, and on top of those convolutions, a max pool is happening. And after that max pool, next layer, next inception module or next layer is getting called. Okay, and in this, error rate has been decreased here to 6.7%. Okay. So next one is very interesting, and it is by Microsoft. That is ResNet. In 2015, they have come up with the ResNet, and which has 152 layers. No one has imagined that using so much number of layers into their neural network architectures. But that, and you can see the error rate is again decreased by half, decreased to half to 3.6%. So that doesn't make any direct relation between the number of layers and your accuracy, because as number of layers, if we are going to increase, then accuracy might decrease, or it has been experimented that accuracy is getting decreased after a certain number of layers as per your the problem statement. Okay, so there are two important attributes of this ResNet, that they have used batch normalization and Xavier 2 initialization, and it is very much faster and performant than the VGGNet. So in the diagram you can see, so normally what happens that whenever weight layer gets an input, it will give us the output, give us the weight as output, and it will be passed through LeLU function for the activation. Same thing with the next layer, but for the next layer here, we are using identity or input directly passed to the skip to the next layer, and it will be considered before the activation of the third or fourth layer, or whatever the layer we can decide. So this is all about the ImageNet. So how the networks and neural networks and CNNs are evolved over the period. So now let's talk about the FaceNet. So first of all, why and what? So these two WH questions are very important about the FaceNet. So despite of the significant advances in the image field, image recognition or face recognition field, the implementing face verification and recognition, doing it at efficiently and at a scale was also a serious challenge with the approaches available at that time. And that's why Google has come up with the FaceNet concept or FaceNet model, I will say. So it directly learns a mapping from face images to a compact Euclidean space where the distances we can directly corresponds to the measure of face similarity, we can say. So various face related or face recognition related applications are becoming easier or can be implemented using standard techniques, and those applications are like face recognition, face verification, and clustering. And one of the most interesting, and I have already told that thing, is it has reached the record accuracy of 99.63% with the wild data set, which face data sets, and with the YouTube faces data set, it has achieved 95.12% of accuracy. So next thing we need to see is the model structure of this FaceNet. So similar structure we have seen while we are looking for the deep learning. So it has a batch layer. So a batch size, so images or input has been taken in a batch, can be forwarded to the deep networking layer or deep architecture. After that, on top of it, it has done the L2 normalization. So output of the L2 normalization is the face embeddings, what we are talking about. So these embeddings are we can treat them as a vectors, and these space embeddings are being passed to the triplet loss. So we have a loss function for each deep learning neural network to calculate the accuracy and to backtrack. So after calculating a triplet loss, it has been passed to the deep architecture to modify the weights, and again we'll get the face embeddings, which we think of as a more accurate than the previous ones. Okay, so we are going to see what is the concept of triplet loss here. So input of this input at time will be an anchor image, positive image, and negative image. So anchor image is nothing but the containing the face of a person which we are going to identify or which we want to recognize. Positive image is the same image of that person, but it might have been taken from a different angle or different lighting conditions, whatever it may be. And negative image is the image of completely different person, not similar or not of the same person. And machine is learning, or network or model is learning to find out or learning to find the distance between the anchor and positive, learning to reduce the distance between anchor and positive rather than the anchor and the negative ones. So that's why if two similar faces can be run through the FaceNet, then they will have the less distance between them, because they have find out the space to create the vectors which are similar, which are quite similar for those images. Okay, so how we have implemented our face comparison module, we can say. So we have created our FaceNet face recognition and face verification application using in the mobile application using Android one. So we have, first of all, we accept two images from the user and resize it. So resize it to compress those images so that mobile can process it efficiently. Then detect the faces from both the images. As FaceNet model works well on the only faces, not on the entire image of a person. So you need to crop those images and provide them only as an input. So for cropping those images and finding out the face area, we have used the MTCNN. After cropping, two cropped images will be sent to the FaceNet model one by one to find out or to get the output two vectors with the 5, 1, 12 dimensions. So we have used the TensorFlow implementation of MTCNN and FaceNet in the Android application. And after getting those two vectors, we have a very popular distance formula, that is Euclidean formula, to find out the distance between two vectors in the space. So we have used that to find out the similarity between these two vectors, and we have come up with the what we can say, the threshold value. So that value or distance between those threshold is less than the distance between those two vectors is less than that threshold, then those faces are of the same person. If it is above or beyond the threshold, then these two faces of the different person. So this is how the application flow works. So now it's demo time. So let's go to the demo video. Let me start. So we have image one and image two concept. We have uploaded image one and uploading an image of a same person and click on compare. So it is saying the same person. After that, if I select photo of two different persons, so you can see very efficiently and very fast it is getting the results. And we have also tried with our images from some of our employees, so that we can check the more accuracy of the system and performance. So we have tried with the celebrities as well as tried with our local employees, because we have also implemented it in our company for the face detection and attendance based systems. So this is all about the FaceNet, overall, deep learning, and the CNNs. So Shweta, that's over to you.
Okay, Akshay, thank you so much for sharing your knowledge. Now we are going to go ahead and take some questions. So just a reminder to everyone, please be sure to type your questions into the question box in your control panel. So we're still waiting for some questions. So guys, if you have any questions, please ask them. All right, so we have multiple questions coming in actually. So we are going to do our best to address them all. But if we are short on time and cannot answer all of the questions, please reach out to us at marketing@nitorinfotech.com and we will respond with answers. Okay, so Akshay, first question for you. How much time and money do you think we can save by building our own face recognition system? Do you have any numbers or examples of this?
Yeah, it's a good question, because all will be drilled down to time and money actually while implementing any application.
Right.
But I don't have any specific numbers about time and money. Yeah, but uh, to create and to implement a very robust security system, face recognition application is very much likely to be that. And if we're talking about time and money, we should implement it fast first, and that's why we can use existing models, as well as we can use the transfer learning concept from the deep learning technology, we can say.
Okay, thank you so much. Next question coming in. Do you think face recognition has the potential to reduce time to market for deliverables? If so, can you please explain why and how?
So so again, it's a same kind of thing. So it will not reduce the face recognition system will not reduce the time to market, but implementation of these systems, if we use existing models again, as well as the cognitive services, then we can reduce our time to market with the top-notch security mechanisms.
Okay, that's great. And then finally, can you just comment on why you decided to go with FaceNet instead of, for example, importing Python libraries to achieve what you just explained?
Yeah, actually that question has been answered, I would say, because FaceNet has a great accuracy and record accuracy of 99.6%, which we cannot achieve by our own, because if we want to do it, then we need to build a deep learning system, as well as we need to have a very high amount of data, I would say, and that only Google and Facebook has regarding the images.
Okay, if anyone has any more questions, we don't really have the time, so I think we will wrap up for now. So it looks like we've covered everything, and thank you everyone for attending. We really appreciate your being here. Akshay, thanks for speaking. Akshay, thank you so much for speaking. I hope everyone has enjoyed this webinar. And please don't forget to follow Nitor Infotech on social media for our latest updates. And of course, you can always check out our website for our global offerings. If you have any more questions or want more information, please write to us at marketing@nitorinfotech.com. Thank you everyone for joining us today, and I hope you have a wonderful evening. Goodbye.